Hello guys, welcome back to our channel. Here we are simplifying complex electrical engineering concepts. We were doing a lecture series on network theory these days. In today's video, we are doing the uh, third lecture on network theory, which is mesh analysis. Mesh analysis is a fundamental technique used to analyze electrical circuit. Let's get started. Mesh analysis is also called loop current method of analysis. Loop current method of analysis is a systematic way to solve currents in a circuit. And the basic thing is that it can be used for a planar circuit. What is a planar circuit? A circuit which can be drawn on a plane without overlapping wires. There is no overlapping wires. So such a circuit is called a planar circuit, and mesh analysis can be used to solve planar circuits. So what are the steps in mesh analysis? So the first step is identify the meshes. Okay, when you get a circuit, first you should identify the meshes. Then you have to assign loop currents. Assign loop currents. So throughout my videos, throughout this uh, subject, we will assign a clockwise current direction. After assigning a loop current, we have to write the KVL equation for each mesh. Write KVL equation for each mesh. So what the KVL states? The KVL states that the algebraic sum of voltages in a closed loop is 0. After writing the KVL equation, you have to solve the equation using either by matrix method, that is using Cramer's rule, or by using algebraic equation method. Okay, so equation solving, we have algebraic equation method and matrix method using Cramer's rule. Now you understood the steps for mesh analysis. So let's see how we can apply these steps on a circuit. Here we have a circuit, and our question is to write the mesh equations for the circuit. We can see that there are three voltage sources, V1, V2 and V3. Okay, so we have V1, V2 and V3 voltage sources, and R1, R2, R3, R4 and R5 resistances. In your syllabus, it is given that we have to study the Kirchhoff's voltage law and Kirchhoff's current law, that is the mesh analysis and the node analysis for both DC circuits and AC circuits. So this is a pure DC circuit because we have only resistance as the passive elements. If we go to the AC analysis, we will be having inductor, capacitor, and resistor. So first we can see how we can analyze or how we can write the mesh equations of DC circuits. Then it will be easy for you when it comes to the AC analysis. So first our step is identify the meshes. If we look at the circuit, we can see there are three meshes. First one is this, second one is this, and third one is this. Okay. Second step is assign loop current. I already said that I am using clockwise loop currents throughout the subject. Okay. Here, this is a clockwise direction for the currents I1, I2, and I3. Okay. If you see that uh, loop current direction is the same is the direction in which we travel also. Okay, it is the through the loop current direction we are traveling in the circuit and going to write the KVL equation. And the third point is to write KVL equation for each mesh. For the first mesh, that is mesh 1, we can draw it like this. That is, we have a voltage source, then we have R1, and then we have R2. And our loop current I1 is flowing like this. So if we check through R1, there are two currents flowing. I1 is flowing in the downward direction and I2 is flowing in the upward direction. Okay, that is this way we have I2. Through R2 we have I3 flowing in this direction. Okay, so by Kirchhoff's voltage law, algebraic sum of voltages in a closed loop is 0. That is summation of V is equal to 0. Okay. So what are the voltages here? Here we can see here there is a node and here there is a node. Between these nodes, voltage here it is negative and here it is positive, right? So as we travel through the current is traveling from this point to this point, voltage is having a rising potential. So we can write it as V1. Sorry, V1. Then when the current travels through this resistance R2, R1, we have already seen it in the sign convention that there will be a voltage drop, that is minus VR1. So because it is a voltage drop, we are keeping it as minus VR1, and minus VR2 is equal to 0. So the voltages, the summation of all the voltages will be equal to 0. When we have a rise in potential, we will take it as positive, and when we have a fall in potential, we will take it as a negative quantity. So between these 2 points, there is a resistance and there is a voltage drop. Between these two resistance, we will be having a voltage drop. So how can you write it? V1 minus current is I1, okay, minus I1 R1, okay, and I2 is in the opposite direction. So we can write plus I2 R2. Or how we can write R1. We can write minus R1 into I1 minus I2. Why? Because I1 is going down and I2 is going up, and it is a voltage drop, so it is minus R1. Okay, similarly for R2, minus R2 into I1 minus I3 is equal to 0. Okay, did you get it? How we can rearrange it? We can write it as minus R1 plus R2 into I1 plus I2 R2 I2 R1 plus I3 R2 is equal to 0. Not 0. We have a voltage source. So we can write it as is equal to minus V1. Okay. So we got I1 term, I2 term and I3 term in the equation. So this is our first equation. We got our first equation. Let's move to the KVL equation of the second equation. Applying KVL in mesh 2. Okay. Mesh 2. Mesh 2 we have voltage source, then resistance, then here is one resistance, then here there is one resistance. Okay, R3, R4, R1, and we have V2, and our current is going like this, I2. Okay, and here we have I3. Here in this direction we have I1. So how we will write the mesh equation? Between this point, voltage is in the negative potential to positive potential. So we have to write it as plus V2 minus VR3 minus VR4. There is a potential drop in each resistance. Minus VR1 is equal to 0 according to KVL. We can write V2 minus I2 R3 minus R4 into I2 minus I3 minus R1 into I2 minus I1 is equal to 0. Rearranging it, we get I1 R1 minus I2 into R1 plus R3 plus R4 plus I3 R4 is equal to minus V2 as the second equation. Okay. We rearrange with I2 we have R3, R4 and R1. With I1 we have R1 and I3 we have R4. Okay. So we got our second equation. Now let's move to the third equation. Okay. Let me write it here. That is I1 R1 minus I2 into R1 plus R3 plus R4 plus I3 R4 is equal to minus V2. So this is our second equation. Moving on, we were going to discuss about the third mesh. So applying KVL to the third mesh, we have R2, R4, R5 and one voltage source. I3 is going like this. V3 is there, R5 is there, R4 is there, and R2 is there. Through R4 there is I2 current flowing. Through R2 there is I1 current flowing. Okay. So we can write, so between this direction, voltage is having a negative potential here and a positive potential here. So as we move from this point to this point, the voltage is increasing. So we can write V3 minus VR2 minus VR4 minus VR5 is equal to 0 according to the Kirchhoff's voltage law. That is summation of voltage is equal to 0. Okay. Summation of voltage is equal to 0. Now V3 minus I3R5 minus R2 into I3 minus I1 minus R4 into I2 I3 minus I2 is equal to 0. That is rearranging, it is plus I1 R2, then plus I2 R4, then minus I3 R2 plus R4 plus R5 is equal to minus V3. So this is our third equation. So we got three equations. Let me write it here. I1 R2 plus I2 R4 minus I3 R2 plus R4 plus R5 is equal to minus V3. So this is our third equation. Now we can write it in the matrix form. How can we write it in the matrix form? In matrix form, we can write it as minus R1 plus R2, R1, R2, then R1 minus R1 plus R3 plus R4, R4. Then R2, R4 minus R2 plus R4 plus R5 into I1, I2, I3 is equal to minus V1 minus V2 minus V3. So this is the matrix form. So we wrote the mesh equations for the circuit and wrote it in, expressed it in a matrix form. You can either, if you know the values of R1, R2, R3, R4, R5 and V1 and V2 and V3, you can solve for I1, I2 and I3 using the algebraic method, that is the equation solving method, or using Cramer's equation you can solve. So the solution of the matrix I'll teach you in another video. So this is just mesh analysis and how we can write the mesh equations from a circuit. This is our topic today. Hope you understood the concept. So let's see one more problem. Our next question is the circuit shown here for writing the mesh equation. So our first step is to identify the meshes. So here we have one mesh, this one, second mesh and the third mesh. And assigning the loop current is our second step. So we assign this loop current and numbered it as I1, I2, I3. Here if you see the question, we can see that the mesh 1 do not have any connection with mesh 3. Okay, so I1 and I3 do not have any connection, so that will be reflected in the mesh equation also. And the third step is write the mesh equation. So we identified the meshes, step 1. Then we assign the loop current. Then the third one is write the mesh equation. So applying KVL for mesh 1, we can write here, as we go from this point to this point, we can see the current is the potential is having a rise. So plus 10 volt. Okay, plus 10 minus, from this point to this point we are having a drop in potential. So minus 8I1. Now here minus 1 into I1 minus I2 is equal to 0. Okay, so we know that delta V is equal to 0. We can write 10 minus V of 8 ohm minus V of 1 ohm is equal to 0. Rearranging it, we can write minus 9I1 plus I2 is equal to minus 10. This is our first equation. Then again applying KVL for mesh 2, we will get what we will get, V of 1 ohm minus V of 1 ohm minus V of 2 ohm minus V of 3 ohm is equal to 0, because there is no voltage source associated with mesh 2. What we can write, minus 1 into I2 minus I1 minus 2 into I2 minus 3 into I2 minus I3 is equal to 0. So if we check the mesh equation, we can write, when we consider the mesh, we always return it as I1 minus I2. When we consider mesh 2, we wrote everything as I2 minus I1 and I2 minus I3. Why? Because we are considering the, at that point, at when we consider that mesh, we are considering I2 to be positive. Okay, all these are our consideration, and if we follow this particular method, if we follow this way only, the our current will be in correct value. Now rearranging this board, we can write I1 minus 6I2 minus 3I3 plus 3I3 is equal to 0. So this is our second equation. Now applying the KVL for mesh 3, we can write delta V is equal to 0. There is one voltage source also. So between the voltage source, as we travel in the loop current direction, we can see it is having a positive potential here and a negative potential here, right? So it is moving from a positive potential to negative potential. So we can write it as minus 20 minus V10 ohm minus V3 ohm is equal to 0. Okay. That is minus 20 minus 10I3 minus 3 into I3 minus I2 is equal to 0. Okay. That is 3I2 minus 13I3 is equal to plus 20. So this is our third equation. And we can again write it as in the matrix form like this. In the matrix form, you can write it as minus 9, 1, 0, 1, minus 6, 3, and 0, sorry, 0, 3 minus 13 into I1, I2 and I3 is equal to minus 10, 0, 20. So in the matrix form, we will get like this. Okay. To avoid common mistakes, you have to double check the conventions, whether it is a rise in potential or whether it's a potential drop. Ensure the shared components have the correct polarity. Let's stop the mesh analysis session here. If you found this video useful, do give a thumbs up and share it with your friends. Don't forget to subscribe for more engineering tutorials. See you in the next video. Bye.